Welcome to Math TV with Professor V. This is Intermediate Algebra video lecture number 9 on solving applications systems of two equations. So in the previous video lecture, we went over how to solve systems of linear equations, two variables, two equations, using the elimination or addition method as well as substitution. So now we're ready to handle application problems, aka word problems, with two variables. And just keep in mind, problems that have two unknowns require two equations in order to be solved. And clearly define your variables and answer each of the problems with a complete sentence, okay? First example, don't be nervous. Here we go. Tanya is a bank teller. At the end of the day, she has a total of 69 $5 and $10 bills. The total value of the money is $590. How many of each denomination does she have? Okay, so first let's define our variables. What are we asked to solve for? The question at the end of the statement says here, how many of each denomination? So they want to know how many $5 bills and how many $10 bills she has. So that should be how we define our variables. I like to just use X and Y. When you get too carried away with weird letters other than X and Y, it just gets too hard to solve the equation, I find. So let's let X equal the number of $5 bills, and then Y can be the number of $10 bills. And I'm going to clue you into a pattern that appears when solving a lot of these applications, okay, for systems of equations. One equation is going to deal with the quantity of items, and the other equation will deal with the value. So let's look at what exactly I mean. Quantity equation versus value equation. We need both. Quantity is just talking about how many bills Tanya has. And it says at the end of the day, she has a total of 69 bills. So we don't know how many X's, we don't know what X is, we don't know what Y is, but all of them together, X plus Y, there's 69 of them. Okay, that's talking about the quantity. The value of the money is 590. So each X, each $5 bill is worth $5. If X was 2, they would be worth $10. If X was 3, it would be worth $15. So the value is 5 times X. The value of however many Y's she has is 10 times Y. And they told us the total value is 590. Okay, and if you keep track of your units, we don't put them in the equations, but if you were to, everything here has a dollar sign in front of it, right? Where in the top equation, it wouldn't, because we're not talking about money. We're just talking about how many bills there are. Okay, so at this point, you should feel like you're in good shape because the equations are written, so the worst part's over typically. This is where most students, have all this anxiety is just with coming up with the equations. Now just solve them, and you can do either method. I don't care, substitution or elimination. We'll switch it up. Let's do, how about, elimination should be fine. Let's multiply the top equation by -10, right? If I multiply by -10, and then the bottom equation, I'll do nothing to, okay? So we'll have here -10x minus 10y equals -690. And then we still have 5x plus 10y equals 590. Add these together, y cancels out, and I'm left with -5x equals -100. Dividing both sides by -5, then you get x equals 20. And then I need y, but you can just easily come here. X is 20 plus y is 69. So subtracting 20, that means y equals 49. You're not done because remember, you picked what x and y represent. Someone else could have done it the other way around, right? They could have let x be the number of 10s and y be the number of 5s, and everything would work out the same. Your values for x and y would just be swapped. So what ultimately matters when you're solving word problems is that you answer the question with a complete sentence, meaning Tanya has 20 $5 bills. Yes, because who cares what X is? They just want you to answer the question. She's got $25 bills and 49 $10 bills. Oh, okay. So don't say X is this, Y is this in your answer. Always answer the question with the appropriate context. Okay? Good. Let's look at another example. Oh Nuts sells pistachios for $10 per pound and almonds for $8 per pound. How much of each type should be used to make a 50-pound mixture that sells for $8.80 per pound? You guys, this is a real company. For years when I would do this word problem, I didn't realize it. And then when I was on Amazon, I actually wanted to order some, I think it was pumpkin seeds, and it was Oh Nuts that had like the best value. Anyways, so we're making a mix of pistachios, yum, and almonds. Okay, and again, we're going to have a quantity equation and a value equation. Yes. So pick your variables. Let's just let X equal the number of pounds of pistachios. And then Y is going to be the number of pounds of almonds. Okay, so quantity equation. It's a little bit hidden, but if you read the question, it says how much of each type should be used to make a 50-pound mixture. So in the end, you want 50 pounds when you mix these nuts together. So that means X plus Y is going to be 50. That's the quantity equation. And then it tells us that the mixture is going to sell for $8.80 per pound. Okay, so hold on. This is what's going on. Pistachios are 10 per pound. Okay, so the value is going to be 10 times X, however many pounds there are. Almonds are 8 per pound, so you've got 8 times Y. No, this doesn't equal 880. It's 880 per pound. And how many pounds are we making altogether with this mixture? 50. So it's going to be 880 times 50 on the right-hand side. Do you see? Okay, good. So we've got 10x plus 8y actually equals 880 times 50 is 440. 440. And then now it's up to you. Do you want to solve with elimination or substitution? You know, because we did elimination last time, let's do substitution this time. So let's solve for x, maybe in the first equation. So x equals 50 minus y, and then I'll substitute that into the next equation. So we have 10 times 50 minus y plus 8y equals 440. All right, now we'll distribute. So 500 minus 50y plus 8y is 440. We have 500, negative 50y plus 8y is negative 42y equals 440. Subtract 500. Oh, it should be 10y. What was I doing so crazily? Excuse me. Okay. 500 minus 10y plus 8y equals 440. So then we have 500 minus 2y equals 440. Okay. Subtracting 500, then negative 2y equals 440 minus 500. That's going to be negative 60. So y equals 30. So that means we have 30 pounds of almonds because y represents the number of pounds of almonds. And then x, which is 50 minus 30, is 20. So 20 pounds of pistachios. So it's almond dominant. How do we feel about that? I like pistachios quite a lot. Pistachio ice cream is one of my favorites. What about you guys? What's your favorite ice cream flavor? Tell me in the comments. Yeah, that wasn't a complete sentence, but you know what? This is good enough. Okay, moving on. Deep Thought granola is 25% nuts and dried fruit. Oat Dream granola is 10% nuts and dried fruit. how much of Deep Thought and how much of Oat Dream should be mixed to form a 20-pound batch of granola that is 19% nuts and dried fruit. So this is essentially the same problem, you guys. We've got two kinds of granola and we're mixing them together to form 20-pound batch that has this concentration of nuts and dried fruit. Okay, so they want to know how much of each type of granola, how much of Deep Thought granola and how much of Oat Dream granola we should mix. I feel like granola is already mixed. Why are we mixing granolas even more? But okay, so let's let X equal the number of pounds of Deep Thought granola, and then Y is going to be the number of pounds of Oat Dream granola. Okay, again, quantity equation. The total mixture is going to be 20 pounds, 20-pound batch. So X plus Y is 20. And then each of these percentages rewrite as a decimal when you make your value equation. So X, Deep Thought granola, is 25% nuts and dried fruit. So 0.25 of X is nuts and dried fruit. Oat Dream, 0.10 times Y is nuts and dried fruit. And we want the final mixture to be 0.19%, but not just 0.19, 19% of the 20. So multiply by that total value there, okay? Good, so here's our system of equations. Let's again try solving with substitution. It's usually less preferred, so we'll do it more so we have no weak points in our mathematical skills. So here's equation 1, here's equation 2. Let's just solve for, let's switch it up. Let's solve for Y in equation 1, okay? So if I solve for Y, I'm gonna have Y equals 20 minus X, and we'll substitute that into equation 2 now. So we'll have 0.25X plus 0.10. Instead of Y, I'm going to write 20 minus X equals 0.19 times 20, that's 3.8. Okay, good. Why don't you guys pause the video, try to solve here, and see how you do. Okay, good. So let's see. Next step would be to distribute 0.25X plus, if I distribute 0.10, yes, we're going to have 2 minus 0.10X equals 3.8. And then here I have like terms, so I can combine them. That's 0.15X equals 3.8 minus 2 is 1.8. Divide by 0.15 and you should end up with X equals 12. All right, good. And then if X equals 12, that means Y is going to be 20 minus 12, which is 8. Don't write an ordered pair for your answer. Just answer the question here. So just give context to the variables. So we'll have 12 pounds of Deep Thought granola and 8 pounds of Oat Dream granola. And you'll see this same problem again, just, you know, with different fake quantities assigned. So instead of granola, you might be mixing like hydrochloric acid in a problem, or you might be making a saline solution, something like that. But it's all the same problem. The setup, the process is all the same. The values change, and then they try to act like it's a new scenario when it's not. Okay, sorry if it's a little bit of a negative viewpoint, but it helps for applications to be less scary when you think of them that way. Okay. All right, next example. 2 cars leave Salt Lake City traveling in opposite directions. One car travels at a speed of 80 kilometers per hour and the other at 96 kilometers per hour. In how many hours will they be 528 kilometers apart? So we've actually solved some of these motion problems already using only one equation and one variable, but now we're revisiting them. So I'll do them with 2 equations and 2 variables, even though honestly I like doing it better with just one. But just since we're in this lesson, I'll do it this way. So to set it up, I do like to make a table for these problems. And remember, we have the relationship that distance equals rate times time. Distance, You have to memorize that. That's not going anywhere. Equals rate times time. Okay, so here's what's going on. We've got Salt Lake City and 2 cars leave at the same time going in opposite directions. One is going 80 kilometers per hour and the other one's going 96 kilometers per hour. And they want to know in how many hours will this distance here be 528 kilometers. How long is that going to take? Okay, so we'll make a table. Put 2 rows, one for car 1, one for car 2, and then the heading is just going to be distance equals rate times time. Okay. So car 1, car 2. Car 1's rate, I'll say that's the slower one. It's going 80 kilometers per hour. The time, we don't know. That's what we're solving for. In how many hours? So I'll just put a little t. Car 2 is traveling 96 kilometers per hour. It leaves at the same time, right? 2 cars leave Salt Lake City. That to me means at the same time. So t is going to be the same for both of these cars. Okay, so let's see here. Car 1 is the slower one. So I'm going to call this distance that car 1 travels lowercase d. And then car 2 is going to travel, if this is d, this right here is 528 minus d. 528 minus d. Okay? So what must be true here? Well, I know distance equals rate times time. So now I can make a system of 2 equations using each of the rows from the table. So what do I mean? I mean for the first row, I could write distance equals 80 times t. And then the second row gives me the equation 528 minus d equals 96 times t. Okay. Now we have a system of 2 equations, 2 variables. Do you see it? And so we can solve if I add these 2 equations together. D cancels out here on the left-hand side. So you just have 528 equals 96 plus 80t, which would be 176t. Dividing both sides by 176, you get t is equal to 3. So we're done after 3 hours. Now, the reason I think it's silly to do 2 equations and 2 variables is because it just really overcomplicates things. Like, you don't need this here. You know the distance car 1 travels. Let's do it again. The old way that we would have done it, which is more straightforward, okay? So I don't know how picky your instructor is. I wouldn't give my students a question like this, but they come up. So here's car 1, here's car 2. I would say he travels 80 kilometers per hour, time t. 96 kilometers per hour, time t. This is 80t, this is 96t. And if they're gonna be 528 kilometers apart, then the sum of those 2 distances better be 528. See how much simpler it is? 80 plus 96, there's your 176t equals 528, and bam, we're back to this step. So I prefer solving these sorts of applications with just 1 variable, okay? But if you're in the sort of class where the teacher wants you to do it with 2 variables, 2 equations, because that's what you're studying, then fine. All right, last one here. Little Alfred. Alfred paddled for 3 hours with a 4-mile-per-hour current to reach a campsite. The return trip against the same current took 7 hours. My goodness. Find the speed of Alfred's canoe in still water and the distance he paddled to the campsite. Okay, so they're asking us to find the speed of Alfred's canoe in still water. So let's let x equal the speed of the canoe in still water. Just how fast it can go No current helping or hurting it, okay? And then we need 2 rows again in our table, one for when he's going to the campsite, one when he's coming back from the campsite. So distance equals rate times time. And notice, when he's going to the campsite, the current is going with him. Why do I say that? Because it only took 3 hours. When he comes back, the current's going against him because it takes longer. It takes 7 hours. So we say that he's going downstream when he's going with the current to the campsite, and upstream when he's coming back from the campsite because the current's going against him. Okay? So let's see, the time downstream was only 3 hours. The time coming back upstream was 7 hours. Poor Alfred. The rate. So when Alfred's going downstream, the current's helping him, right? And the current goes how quick? What's the speed of the current? 4 miles per hour. So the rate, the net rate, right, net speed with the current is going to be x plus 4. However fast Alfred's canoe goes. You know, it's him canoeing, huh? It doesn't have a motor. A canoe does not have a motor. Look at Alfred go. And then upstream now, the current is working against him. So it would be x minus 4. Not 4 minus x, x minus 4. U and then the force of nature. Okay. And then the old way that we did this, okay, you would just take these 2 columns, multiply them since distance equals rate times time. And then here you would write 3 times x plus 4 and 7 times x minus 4. That's how we did this in the previous lessons. Now instead, since we have 2 equations, 2 variables, whatever, we're going to call this distance lowercase d, and the distance downstream is the same as the distance upstream. So if we're going to write 2 equations, we'll have d equals, I'm going to put the 3 in the front so it doesn't look weird, times x plus 4. And then same thing over here. D equals 7 times x minus 4. And then since both of these are equal to d, then you can just set the right-hand side of the equation equal to each other. So we have 3x plus 12 equals 7x minus 28. Okay? And then just solve for x. So I'll subtract 3x from both sides. So 12 equals 4x minus 28. Add 28, so then we have 40 equals 4x, so x equals 10. So that's the speed of the canoe. So Alfred paddles, wow, 10 miles per hour in still water. Is that good? I don't know, I don't canoe. And then they also asked what's the distance that he paddled to the campsite. So you can plug in 10 for x either here or here to get the distance. Let's just do the top equation. So the distance is going to be 3 times 10 plus 4, so 3 times 14, which is going to be 42 miles. So he camped 42 miles away. Oop. All right, so that's it. That concludes my examples for you. You should be good to do your homework assignment. And then in the next video coming up, we're going to look at solving systems of equations with 3 variables. Okay, exciting stuff. So give this video a thumbs up, subscribe if you haven't already, and stay tuned. I have so many more good algebra videos coming your way.